Hello, everyone. Uh, it's fun that last time when I did this, there are thousands of people sitting in front of me. Time is such a thing. Times have changed. But it's also important today. We're going to talk about time as an important concept and how that makes our lives difficult as programmers. Back 20 years back, when I was working at Sun Microsystems, JAX RPC was much more popular with Jackson. Whenever there was asynchronous programming or timing involved, we always had trouble. But today, with the recent stream process, and we are treating data as something continuously coming and processing it, things have changed. The stream processes have evolved a lot, and how the storage systems have kept pace with it, how they've evolved, and how the marriage of these two together is what I'm going to talk about. Time is such a beautiful thing. So let's go with it. And by the way, even if it's boring, stay on till the end because I have an exciting new announcement to make about a new product that we want to announce today at Flink Forward. Okay, so today, one of the some of the problems of adopting to streaming, I've listed them all out there. We're going to talk about how we're going to reduce the infrastructure complexity, how we're going to make the programming much more simpler, both from a stream process side and from a storage side, and how both together make it much better. And how are we going to reduce the storage inefficiencies that have become rampant these days, right? So let's get going. Um, and at the end of it, we will show some of the demos and some of the places where this is getting used. And you'll be surprised. The sort of applications that are being used, the swath of applications that are being used are all over the place, whether it's small, tiny bits of data coming from a sensors or huge videos coming from cameras, drones, and other things, whether it's connected cars, whether it is automatic driving, all kinds of different scenarios we see streaming being used. And I'm going to talk about our product, Dell EMC Streaming Data Platform, which is primarily made up of three open source products, Pravega, Flink, and Kubernetes. In fact, you can put them all together and build this product, but it comes with all the enterprise grade features that are necessary for someone to keep using it on the cloud or on-prem and all those things. Okay, we'll talk more about it, but before that, let's talk about Pravega. A lot of people know about Flink, and there are other conferences take care of Kubernetes, so my focus is Pravega. I want to make a bold statement here. Stream is the new file. What do you mean by that? If you think about it, files have been something that we have been using for time immemorial. They're ubiquitous. The abstractions are very clear, and people have been using for a long, long time. Now, but is file the right abstraction for continuous data processing? Uh, the one which we are more worried about when time gets involved. How do really files deal with it? In fact, if you look at the world today, the way people do it is, it's data coming from different sensors and logs. Typically, people use some messaging system like Kafka and then Flume, and then kind of move them into a file system. So what comes in is really uh, in terms of streams, but what goes out is in terms of files, right? But I'm going to say that the stream abstraction is much more powerful. And it's even more powerful if you keep it as a stream abstraction all through, right from the time of ingestion to the time you want to delete the data, instead of having some kind of an aggregation mechanism in front of it and then converting into files. The stream abstraction is what Pravega offers. And what is the stream abstraction? Is very simple. You write always at the one end, and you can read the tail reads immediately because whenever they come, they tell you the tail reads. Or you can start from any offset and read from there. Also, it also has all the scale out and other properties that I'm going to talk about, and that's what makes it much more powerful than a file abstraction for continuous applications. First of all, scaling. So the streams that Pravega offers is something which scales based on certain policies, based on the ingestion volume load or how back are the readers. and reading it. So basically, your routing key and the range of routing keys becomes the stream is subdivided into segments and automatically divided into segments. You don't have to do anything about it. And each segment is nothing but a range of routing keys and which varies dynamically over the lifetime of the stream. Now, how do we do this in file? You have to create new files because you want to create parallelism by writing to more segments. So that's the whole idea of why you have segments. In case of files, you have to split into multiple files. It's not transparent. You have to manage these multiple files whenever you have to increase the parallelism, both from the read side and the write side. This is automatically taken care of you by a stream abstraction system like Pravega. Again, the read order. Read order is simple. If you have a single file and you're reading, obviously you'll get it in order. But when you have this dynamic scaling, when the range of the routing keys are assigned to segments dynamically, it becomes very hard because you have to manage it yourself somewhere else. File doesn't give a direct concept like that to you. Third thing is time and positioning. And I'm going to introduce a concept called stream cut much later, but think of it is that you want to draw a line somewhere in the stream, even if it spans multiple segments, you will have that. In case of files, because you're dealing with multiple files and you'll have multiple offsets for each file, then you have to manage that somehow. The concept of time doesn't come automatically to you, right? So another thing is checkpointing. You're all familiar with Flink programming. It has a checkpointing mechanism. You can go back in time and start processing from there. And this is primarily how Flink provides exactly one's guarantees for a job. And if the storage system provides that concept, it is much more powerful. And I'm going to talk about stream cuts uh, soon and watermarks, two facilities that we provide. So in short, uh, I can write these things. And stream provides low latency failure. It's very, very important, particularly for stream processing. Files don't have a concept. You have to keep pulling it all the time. Uh, Streams provide transactions. In fact, transactions across multiple segments. It's not possible. Or it's possible, but we all know how hard it is to provide transaction across multiple files. And then truncation of head of stream is a very simple thing. And if you want to delete or truncate your stream, it comes much more naturally with the stream. So in any case, in short, what I want to say is that we have been using files and we have been very happy uh, using files all through. But I wanted to make this point for continuous processing. Stream provides a much better abstraction, and the time concept is dealt with very, very well. Now, Pravega is streams. How to make this whole concept really operationalized? And Pravega is a product. It's an open source part, Apache 2.0 license that you can all use. One of the fundamental things that we have given in Pravega is event is an application concept. And it's up to the application to define what an event is and what it represents. At the core of Pravega, events are sequence of bytes, and Pravega does not try to make sense of the events. We expect the application to pass the serializer, and ultimately Pravega just stores a sequence of bytes. And why is this relevant? It's relevant because now, whether it is a small event coming from a sensor or a big video coming from drone, it doesn't care. We're able to store it, we're able to process it, and all these kinds of different data types are able to participate in real-time applications. And now I want to show an application for you. This is an application where you have multiple security cameras sending the data to Pravega streams. And then you have a Jupyter notebook where you can see the stream. And let's roll the video and see this demo. So you can see the stream coming. I'll press live This is the live data coming. You can see it. And if you look at the time, we're taking around 20 milliseconds to show the live video. Remember, this video is coming into Pravega, and then through Jupyter Notebook, I'm showing the video live. It's very simple, nothing spectacular about it. Now, as I said, there are multiple cameras feeding. If I go to a different camera, and you can see the live stream from that camera, or third camera, fourth camera, you can go and see this from different cameras, all live data coming in. Pravega is showing it. It is storing it and showing it. Now, that's nothing fun, but it is accessing as a DVR. You can fast forward, you can go back, you can stop it wherever you want. In fact, you can even go back and play it from wherever you want. So just like you do with any DVRs, right? And all this is done through Pravega streaming data platform. You can see into the dashboard and see what is the ingestion rate of the data coming in, what is the rate at which you are reading the data. And one important thing I want to pay attention to the retention. Right now, it shows the retention as infinite, means you can keep the data forever, right? It's important because Pravega is not just a messaging system, it stores and also stores for a long term. So you can retain it for however long you want. You can go into the dashboard and change the retention policy as either by time or by size. You can change the retention policies either ways. And that's how we are able to do a DVR kind of thing, go back to wherever you want and start playing it time again, we can go back and forth in this and can see. Okay, so people might say, oh, that looks like a simple demo. What's the big deal? I've seen a safe-based security cloud doing this all the time. The data is coming in and seeing in cameras all over the place. Yes, it's interesting. But why I want to show is first is Pravega. You can ingest videos directly and see them. One thing, that's our two-tiered storage system helps with that. Second, I want to now introduce how do we really process it. Now, when we add Flink to it, it kind of starts getting interesting. Time again, important aspect. Now, the next demo I want to show, same data is coming from different cameras to Pravega, and a Flink job reading those streams and writing to an output stream. Now, what it is doing here is that it is time aligning the videos. Even if those videos are sending the data at different frame rate, it time aligns them and shows them live to you. Let's go see that. So here is the data. I press live and it comes from 4 different cameras. The most important thing is it's completely time aligned based on a watermark that you have created at that point of time in the videos. And even if they are at a different phases, you can still see the videos, right? So that's one important concept. Now let's get back to the slides. Now, so one of the things that I talked about is watermarking, and the other thing I talked about is stream cuts. These are two important concepts which helps us to provide a time concept from the storage system itself. A stream cut represents a consistent position in the stream. It contains a set of stream segments and offset pairs for a single stream, which represents a complete key space at any given point of time. The offset always points to the event boundary, and hence there will be no offset point to an incomplete event. That's basically a stream cut. So you can draw the line anywhere across the different segments. Now, why is this important? Let me show the next demo. So the first 2 demos is very simple. We're just getting into it. Trust me, the next demo is about actual detection. You have a machine learning algorithm running on GPUs, which is taking the raw videos coming from the cameras, detecting the objects, and the labeled video with all the metadata is again written as streams by the Flink object back to Pravega, and we're showing it through a Jupyter notebook. So let's play the video to see this demo. Okay. You have this video and it's live, a plate. You can look at it. It shows it's a car, it's a person, and the number next to it is the confidence with which it can detect it's a car. So this is the live data coming. As the data is coming in, you can see that it is processing and telling us, identifying, and you can see the time it taking around 1 to 2 seconds for this to process. The data is coming in from the cameras. Flink is reading it, detecting it, and then entering it. Now, since the output stream not only has these boxes but also metadata, I can query the output stream and see what all it is detecting. It shows for each camera what it has detected. Like, for example, in this camera 0, it has detected 23 bicycles, right? Camera 2 has 3 bicycles. Like that, I can look at it. In fact, I can query and see where all it has detected buses. See, if I run this query with bus, I can see with camera 4, there's 461 buses. So let's go down and see this. Wow, there's a problem here. There is no bus in the image, and I see a bus. So let me go and actually change the model. Actually, I'll just change this threshold here. I go to the code, change the threshold. And by the way, I'll just want to deploy this to my desktop to check it out. And to do that, I don't want to run on the whole video. Remember, I explained you the stream cuts concept? I go there and edit the start and end stream cut, right? And then deploy it on my desktop with this changed parameter. Here, I'm going and changing the stream cut. I'm looking at the stream cut at the video frame that we have seen, and then we rerun it again. And voila, when bus is gone, it's not detecting bus at the same place again. See that? Now I'm feeling comfortable about it on the desktop. It looks good. Let me go and redeploy it on my production system. Think about it. We can go back and process from anywhere you want. You can process the live data. You can go process. And now again, go live here and process it and see it is detecting persons. It's not detecting bus when it's not there. And live goes happily ever after, detecting coolly what we want to detect. So that's the third demo that I wanted to show. Let me get back to the slides. Now, another important concept that we have done with Pravega is this. I already explained how segments keep growing up and down over the lifetime of the stream. But how can Flink really take advantage of it? And we're working with Flink, and the next version we're going to release where Flink can automatically scale up and down, change its parallelism based on number of segments in Pravega. And we can also use Pravega Sync because Pravega provides exactly once guarantees, just as Flink provides exactly once for a job. Across a string of Flink jobs, now you can provide exactly once guarantees. You can provide auto scaling so that things can go up and down. I mean, the number of parallelism can go up and down as we go. And one of the things that we have seen is, remember I told you how it is very important to treat everything as bytes of things. That's why we're able to process drones or other things. I want to show a video of one of our customers who are using this for an application where it's a construction company which looks at the construction website and sees the drone images and see how it, first let me play the video, roll the video.
Today, real-time business information streams in from many sources. iNet Corporation uses data from drones and smart sensors to monitor a construction site. iNet has the ability to easily roll out this real-time edge monitoring solution at a construction site without a primary data center. Using the Dell EMC streaming data platform allows iNet to ingest, store, and analyze real-time streaming data like locations and atmospherics from smart meters and drones. This provides immediately actionable insights for improved resource allocations of equipment, materials, and people, as well as utilizing weather data for more efficient scheduling. iNet can even use the data to compare progress of the physical build alongside site renderings. Running the Dell EMC streaming data platform allows iNet to obtain real-time insights on their construction project. Simultaneously, they are assured that their ever-changing volume of data is safe, secure, and allocated appropriately for immediate actionable information at their fingertips. The future of storage is here. and so much more.
Yeah, so what I wanted to explain there is two things. iNet is capturing data through iNet, and also the sensors are sending the data all over from different places on the construction website. What they're doing is processing the data, first the videos, to ensure that the correction is going according to the plan. They have a secret sauce to kind of, and AI ML algorithms which check against the digital plans they have and see if the construction is going right. They also have the sensors and they have the automatic detection of different vehicles in the construction site so that they can take an inventory of which is being used where and all that. The most important thing is why Pravega and Flink come together and do a good job here is the fact that you can process videos, you can run computer vision algorithms on videos, you can also get sensor data and can whatever might be the data that is coming in, it is being processed and used appropriately in a real world use case. And that's what I wanted to show. The next is again by a university in Germany. And let me show their website and then we'll talk about the use case. Let me roll the video first.
The future of manufacturing technology begins here. The Laboratory for Machine Tools and Production Engineering, researching the limits of forming and machining technology. Our manufacturing processes are monitored by modern data analytics and secured by distributed ledger technologies. Benefit from the Internet of Production directly in the hall, quickly and securely. Thus, we get the maximum out of your processes. Always one step ahead.
Srikanth, this is Anna. Is everything okay for you? Because the video just paused.
The video is choppy. It's buffering a lot. And we are almost done, 2 more seconds.
I don't think the video is playing for the audience.
Oh, is it?
Yeah, it seems that it's ended, so maybe we'll just go back to the slides.
Play it once more.
Sorry about that.
The future of manufacturing technology begins here. The Laboratory for Machine Tools and Production Engineering, researching the limits of forming and machining technology. Our manufacturing processes are monitored by modern data analytics and secured by distributed ledger technologies. Benefit from the Internet of Production directly in the hall, quickly and securely. Thus, we get the maximum out of your processes. Always one step ahead.
Okay, so sorry for the first time, it was a little bit choppy. I believe the second time it played well, at least for me it played well. So the important thing is they're using a streaming data platform, a combination of Pravega and Flink for, they call it Internet of Production. But primarily, the important thing for them is as data is coming in, they want to auto scale and be able to increase their compute because different things send data at different times, particularly when the production is ramping up, the volume of data suddenly increases for them. When that is happening, one of the features they really liked about Pravega is the auto scaling, as I explained here. And the second thing is providing this exactly once guarantees between different Flink's applications using Pravega as the sink is something that they have been very successful in using. And that's what I wanted to show with that application. Bottom line is, we can all theorize, we're all computer geeks, and we can claim stream is a new file, and I can say a lot of things. But at the end of the day, only when customers really use it, take advantage of it, leverage the features, we all feel happy. We all feel comfortable with the technology that we have produced. And today, I wanted to show with Flink and Pravega, the large swath of applications, whether it is a simple Safeway security guy sitting and looking at cameras to an automatic car detection or ADAS kind of applications to drones being sent and trying to see our construction efficiency, taking data from different places, managing the scheduling, detecting your different equipment there and ensuring they're in the right place, to Internet of Protection, where they are in a fine blanking process, which is what they call, they're ensuring that they don't produce wrong stuff, and it detects these things, anomalies whenever it happens, and immediately raises the alarm so that they can reduce the defective parts manufactured. So varied use cases. Why? Because you can ingest anything, you can scale easily, and you have Flink, and you have time, which is provided by two concepts. One is the watermark, or one is the stream cuts that I explained. Another thing is watermarking. Think of it when the segments scale automatically and you're doing historical stream processing. Today, we don't have a good mechanism to ensure that you provide consistent results when the segments keep changing with the existing things. But with Pravega and Flink, with watermarking, we can do that. I would encourage you guys to go and look at our website and blog to understand this concept a little bit more. We don't have time to get into the detail of it. But today, I want to do one more thing. I want to announce a new product. In the starting, I mentioned that we are reducing the infrastructure complexity, but here I showcase how. Now, first of all, today, if you have any continuous application or even any data application, you have data being stored in different places. Maybe it's an object store, maybe it's in Kafka messaging system like Kafka or RabbitMQ, or maybe it is in a search engine like Elasticsearch or Splunk or all of these people. Every time the same data is getting replicated all over the place. And that's what is causing a lot of inefficiencies. Well, today we want to put an end to this, and we want to actually showcase a particular product which actually takes this. What I mean by that, in Pravega, as you ingest the data, you know that it already acts like an ingest buffer, pub/sub, and all those things. But as you ingest the data, what if we do in real time index the data as it is coming in and store the index in Pravega itself, because it's a scalable scale-out system, and be able to query or do a text-based search on top of it? Then you don't have to store again in multiple storage systems. You can store the raw data in one place and being able to do different things, run Flink jobs on it like we did in the previous application. And now you can do search on top of it also. And that's what we have come up with a new product called Pravega Search, where in conjunction with Pravega and of course Lucene, which is the most popular indexer on the earth, we are able to now streaming data. You can do the Flink jobs like we did before, but we automatically, if you need to, index them and store them in Pravega back. So you don't have to pull the data into separate storage system, and then you can run queries on top of it. You're using Lucene under the covers, but you're using Pravega for all the scalability that comes along with it. So you don't have to reinvent, you don't have to rebalance, you don't have to do all those things. But all the rescaling and other features of Pravega, you can look at the other demos that we have given in Flink Forward before. But today we want to really showcase the applications that can be built on top of it, one, and then how we can reduce the complexity of infrastructure by doing things like search on top of it. Now, how the string things works, the input streams as they're coming from the digital world are stored in Pravega. And the most important thing, and the output of the search could be again be input or a trigger for a Flink job. And that now is very exciting to kind of see a lot of other applications. In next year, probably we will come out with a good customer use case which showcases this. But think of it, two things that we can't do with the current search engines. We can now do a continuous query. Isn't it very exciting that you can do continuous query? As the data is streaming in, you can trigger off a continuous query and keep it running. And whenever things happen, one of the favorite things I do is I sit in the office, keep working till the traffic on I-90 reduces, right? I can queue a continuous query. When the traffic speed, average speed increases based on the data coming from cameras, public cameras, if the speed increases more than 40 miles per hour, let me know so that I can go home. I don't want to sit waiting in the traffic. So that's an example of a continuous query. You can do continuous queries like that. And more importantly, even if you're not doing a continuous query, you're reducing the storage infrastructure necessary. You don't have to duplicate the data. You store it once in Pravega. You run your real-time jobs. You can run your batch jobs, and you can now run your search queries on top of it. And that's Pravega Search. And we are going into beta next month, May. We'll be announcing today that we're going to beta next month, May. And in summer, we're going to launch it as a full-fledged product. So that's the exciting thing. And we start with search, but there could be other things. The whole idea is to let's relook at the whole thing. Let's not patch things in the continuous world. Continuous world offers both different kinds of applications that are now possible. It also offers mechanisms by which we need to rethink about the middleware, like for example, search. And I would encourage other companies to look at other kinds of middleware that can be built on top of Pravega to leverage the property, the scalability, the automatic scaling, transactions, exactly once, durability guarantees, all that it provides. And Pravega Search is one such example of a middleware that can be built on top of Pravega, which reduces the complexity, both from an infrastructure perspective, reduces the storage use. And more importantly, it now allows you to have newer kind of applications to be built, whether it's a continuous query that I talked about, or it could be input to Flink and you can do processing. Well, this is what I call a stream-oriented approach to search, really. And as I mentioned to you, and the top is how you do traditional search infrastructure works, and the bottom is how Pravega works. And primarily, this is how you reduce the storage requirement on the product. And of course, it's all kind of deployed on top of Kubernetes as containers. You can deploy in a small system like an edge system or in a data center. We have hundreds or thousands of machines. It could be on the cloud. It could be on-prem, wherever it is. That's what the whole streaming data platform product from us ensures that you can do all those things. Okay, as I started with, we have Pravega, Flink, and Kubernetes, which form Delium's streaming data platform. I want to talk about three things, right? One is how a stream is becoming the most important storage concept for continuous applications. And I showed you with how time becomes important, how we used stream cuts or watermarking in our applications. It showed you how we can leverage pings and powerful stream processing capabilities, both for doing historical processing with watermarking. You can get accurate, repeatable results for historical stream processing, even if you are partitioning changes. And finally, we showed that this all works on Kubernetes because that has become the de facto orchestration mechanism these days. And we built everything on open source. There is no secret sauce. It's all open source. It's just that all these things come together to kind of make. And the fourth and most important thing is how can we build different middleware in this continuous world or in the streaming world? And we have shown with Pravega Search it's possible, and the advantage it gives both in terms of how it opens up different kinds of applications and also how it reduces the complexity. And thanks a lot, guys. That's what I wanted to cover today in the keynote, and very, very excited about the other keynotes. And I encourage you guys to watch the presentation to learn more about Pravega from Flavio and Tom, which was done yesterday. If you've missed it, it'll be recorded by Pravega guys. You can watch it. Thanks a lot.